An Introduction to Batteries from Battery University. In 1800, Italian physicist Alessandro Volta invented the first true battery by stacking discs of copper and zinc separated by cloth soaked in salty water. The building blocks of a battery are the cathode and anode isolated by a separator that is moistened with electrolyte. Positive ions move from the anode to the cathode through the electrolyte and the separator. Negative ions move in the opposite direction. Electrodes. Cathodes are made of metal oxide and anodes are made from carbon. Metal oxides are crystalline solids that contain a metal cation and an oxide anion. They typically react with water to form bases or with acids to form salts. Oxides are binary compounds of oxygen with another element. Most oxides form in soil. All oxides have a very low solubility at common soil pH. Pathogenesis is the process of soil formation as regulated by the effects of place, environment, and history. Biogeochemical processes act to both create and destroy order within soil. The anode builds up negative charge and the cathode builds up positive charge, creating the cell voltage. During discharge, the negatively charged anode releases electrons and the positively charged cathode absorbs electrons. For a good electrochemical cell, you want a cathode with a large positive reduction potential and an anode with a large in magnitude negative number reduction potential. Voltage potential becomes stronger the further apart the affinity number. Affinity is a tendency of a chemical species such as an atom or molecule to react with another to form a chemical compound. The less valence electrons an atom has, the least likely it will gain electrons. Electron affinity decreases down the groups and from right to left across the periods on the periodic table because electrons are placed in the higher energy level far from the nucleus, thus a decrease from this pull. In the case of electrochemical cells, an oxidation reaction occurs at the anode, producing the electron negative charge that flows out of the cell through the external circuit, and a reduction reaction occurs at the cathode surface to consume the electrons coming from the external circuit. The positive and negative current collectors provide a pathway for electrons to flow through an external circuit. Negatively charged electrons flow through an external load from the anode to the cathode, creating a current in the opposite direction. A load defines the current that is drawn from the battery. The sign convention for a positive current is in the opposite direction of the electron flow. During charge, the process is reversed and electrons are forced into the cathode, now the negative electrode. Reduction potential. In a battery, the cathode is known as the oxidizing agent because it accepts electrons from the anode. The anode is known as the reducing agent because it loses electrons. Reduction potential is a measure of the tendency of a chemical species to acquire electrons from or lose electrons to an electrode and thereby be reduced or oxidized respectively. Standard reduction potentials are used to determine the standard cell potential. The standard reduction potential and the standard oxidation cell potential can be combined to determine the overall cell potentials of a galvanic cell. A galvanic cell converts chemical energy to electrical energy. The standard cell potential is the potential difference between the cathode and anode. Reduction potential is measured in volts or millivolts. When solving for the standard cell potential, the species oxidized and the species reduced must be identified. The oxidation state of an atom should be high if it is to be an oxidizing agent, and low if it is to be a reducing agent. Strong oxidizing agents have unfilled orbitals at low energy, and strong reducing agents have high energy electrons. The standard oxidation potential is much like the standard reduction potential. It is the tendency for a species to be oxidized at standard conditions. It is also written in the form of a half reaction. The standard oxidation potential and the standard reduction potential are opposite in sign to each other for the same chemical species. Standard reduction or oxidation potentials can be determined using a standard hydrogen electrode. Electron transfer is a mechanistic description of a redox reaction wherein the oxidation of the donor and reduction of the acceptor occurs. Electron transfer occurs when an electron relocates from an atom or molecule to another such chemical entity. Spontaneous electron transfer occurs between stronger oxidizing and reducing agents to produce weaker reducing and oxidizing agents. Weak reactants do not produce strong ones. The activity series is a chart of metals listed in order of declining relative reactivity that allows us to predict the relative reactivities of different materials when used in oxidation reduction processes. The top metals are more reactive than the metals on the bottom. The driving force behind many redox reactions arises because the acceptor orbitals are much lower in energy than the donor orbitals. The most abundant redox active metals are the transition metals, iron and copper. Transition metals are elements whose atom has a partially filled subshell and which can give rise to cations with an incomplete d subshell. A subshell is a subdivision of electron shells separated by orbitals. Subshells are labeled S, P, D, and F in an electron configuration. The four different types of orbitals, S, P, D, and F, have different shapes, and one orbital can hold a maximum of 2, and one S orbital can hold a maximum of 2 electrons. The P, D, and F orbitals have different sublevels, thus can hold more electrons. Many of the physical and chemical properties of elements can be correlated to their unique electron configurations. The valence electrons in the outermost shell, are the determining factor for the unique chemistry of the element. Electrons in outer shells have higher average energy than those in inner shells. For a good electrochemical cell, you want a cathode with a large positive reduction potential and an anode with a large in magnitude negative number reduction potential. Voltage becomes stronger the further apart the affinity number. Electron affinity is defined as the amount of energy liberated when a molecule or neutral atom acquires an electron from the outside. In general, electron affinity increases or becomes more negative from left to right across a period. This is due to increasing effective nuclear charge, which more readily pulls these new electrons in. In general, electron affinity decreases or becomes less negative from top to bottom down a group. Generally, nonmetals have more positive electron affinity than metals. Atoms such as group 7 elements, whose anions are more stable than neutral atoms, have higher electron affinities. Unlike ionization energies, which are always positive for a neutral atom because energy is required to remove an electron, electron affinities can be negative. Energy is released when an electron is atom. Positive energy must be added to the system to produce an anion, or zero. The process is energetically neutral. This sign convention is consistent with a negative value corresponding to the energy change for an exothermic process, which is one in which heat is released. Ionization energy is the minimal amount of energy required to remove the most loosely bound electron of an isolated neutral gaseous atom or molecule. The greater the ionization energy, the more difficult it is to remove an electron. The ionization energy may be an indicator of the reactivity of an element. The first ionization energy of boron is less than that of beryllium, and the first ionization energy of oxygen is less than that of nitrogen. The reason for this discrepancy is due to the electron configuration of these elements and Hund's rule. Hund's rule states that electron orbitals that are degenerate are first half filled before they are totally filled. Degenerate means that they have the same amount of energy. Inductive effect is the effect of the transmission of a charge through a chain of atoms, resulting in a permanent dipole in a chemical bond. Electromeric effect is the complete transfer of pi electrons in a molecule in the presence of an attacking agent. Intercalation. Intercalation is the reversible inclusion or insertion of a molecule into layered materials with layered structures, a process whereby a guest molecule or ion is inserted into a host lattice. The structure of the guest host or intercalation compound is only slightly perturbed from the host structure, and the reaction used to form the compound is reversible. Often the driving force for intercalation is a redox reaction, i.e. electron transfer between host and guest. Typical batteries use intercalation. In three-dimensional systems, the sizes of the guest species are constrained by the dimensions of the host lattice. In lower dimensional systems, no such restrictions exist, and the strongly bonded layers or chains can adjust their separation freely to accommodate guest species of different sizes. With increasing guest size, the structural correlation between layers or chains is diminished, and in a limiting case, complete separation of single layers or chains occurs in solution, resulting in the formation of colloidal dispersions. A colloidal dispersion is composed of solid, liquid, or gas particles dispersed in a continuous phase, solid, liquid, or gas. Most commonly encountered colloidal dispersions are solid-liquid suspensions, liquid-liquid emulsions, gas-liquid foams, and solid-gas aerosol dispersions. Thank you so much and have a good day.